How do you test and measure the performance of your rockets?
Testing wise, we try and do all our testing at Midlands Rocketry Club. As we said before, the Rocketry Club and the little field that we get to launch out of basically means that we can build our hardware and launch our hardware to much lower altitudes. Granted, it's not liquid propulsion, and actually get some really good measurements from it. See if the designs that you've laid out have worked. I wouldn't say for most. So obviously there are flight computers flying on all our rockets. We'll get acceleration data. We'll get a sort of profile of the flight, GPS track of the flight. You'll understand all of that. How much of a success it was. I think, like Dominic said before, our main goal is always functionality. If you've designed something to do X, Y, and Z and it does X, Y, and Z, then we are in the clear. We're absolutely in the clear. I know that when it comes to the liquid engines and testing at airborne, there are some very fancy data acquisition systems.
Yeah.
I'll talk about.
So, I mean, for the engine, it has many nicknames, pincushion being one of them, from the number of thermocouples we had. And we might have overdone it with the thermocouples, maybe. But again, we were testing it airborne, which isn't cheap for a day outside of Racer Space. Luckily, Racer Space it's funded, but we did one earlier, and we wanted to make the most of the facilities they had there. So they had this amazing DAC with lots and lots of inputs. I think they've up to 32 or something, but we use 24, I want to say, for thermocouples and pressure transducers and things like that. Because while the engine worked and all of the sensors gave fairly unsurprising readings, had it have not worked, that sensor data would have been so valuable in figuring out what went wrong, which was the main issue, I'd say, with Sunfire 2. It had its issues, but I think the biggest issue was the fact it didn't have barely any instrumentation. So the channels failed. We are still not 100% sure on exactly why. There is theories that are more likely than others, but there's not I wouldn't say enough concrete data to back up some of those claims. So we were just like, okay, we'll change what we can to get it working on the new engine, but if it doesn't work, we want to know why. So that's why we have so many thermocouples and pressure transducers dotted around the engine. And luckily they all said, yep, all works good. So that's why we're stripping a lot of them off for the next engine, because we know it's a decent enough system. And also for our test stand as well, we are looking at kind of lab jacks and stuff like that for data acquisition, just keeping it simple like that by using commercial stuff. And yeah, so I'd say that's the main thing, at least from the liquid side of stuff.
Do you use AI during the design process of your rocket?
No, I think I'd ban anyone from doing that immediately. I'm a skeptic of AI, just in general. I think that it's a brilliant tool at the moment. I think it sorts through an incredible amount of data, but most of the generative AI, we're talking about generative AI, the algorithms are based on probability, which means it is actually rolling the dice to try and get it most accurate. But in rolling the dice and trying to figure out the answer through sheer probability, it is going to lie to you. It is going to come up with random stuff that you don't really understand, or literally has no logic, because it is randomly generated sometimes. It's randomly generated and then tested and compared against actual data to see how accurate it is. So I think that when it comes to AI, especially in engineering, I think it's going to take a long while for AI to sort of get to the point where it can design things well enough that we can guarantee as human exactly how it works, understand all the reasons why the AI put all those design decisions in, and not just have random design decisions in things. Especially in aerospace, you want to know why everything on the rocket is there for a very specific reason, and you want the logic behind it to be traceable back. And I think if you use AI in design, that's going to be a little bit difficult. In the same way, you're not going to get an AI flying an aeroplane anytime soon, because if the aeroplane crashes, it's going to be near impossible to figure out exactly why the AI made the decisions that led to the aeroplane's crash. Like the logical chain that goes backwards is very difficult to see. However, with that being said, I think when it comes to data and sorting out stuff, like if a new AI came over, like an organizational AI, and sorted out our Google Drive,
Please.
I could see that being really, really, really useful. But when it comes to design, I don't think I'd want to use it yet. I don't know. What do you think on it, Dominic?
I mean, in terms of when I use it, of course I use ChatGPT for coding because I'm quite crap at coding. So if I need a bit of help with that, then I just ChatGPT, how do I do this? And it does help. Of course, I'm not over reliance on it. And I think a lot of the kind of generative design stuff recently is within additive manufacturing, 3D printing, and I'd say there is use cases. In engines, it's kind of tricky because if you want X amount of thrust, you need this shape of engine. There's not really that much ambiguity to that. Of course, there is stuff you can do with cooling channels or like support structures, because you have that kind of added freedom of you can make pretty much any shape with metal 3D printing. I wouldn't like using it for the sake of it, because if you do need something like, I don't know, I wouldn't say I've got enough experience with it to properly comment on it, I'd actually say.
Yeah.
I think it will be very useful in years to come. There will be very definite use cases that will become, day to day for any engineer. But I think, like Merlin said, the thought process to get there and the actual justification of design decisions, and also just being aware of all of the physical factors that play into it. You need to give, like, the AI doesn't come up with new concepts, really. I mean, I'm not a computer scientist, so I might say something that's completely wrong. I want to make that absolutely clear. But you feed it the data and it gives you a result based on the data. So it can't come up with something that's outside of that data set. And I think that, I mean, humans, it's kind of the same thing. We learn stuff throughout all of our childhood and throughout all of our life. We are taking in information that we can then apply. But because as humans, we have such a wider array of stuff we take in than AI, than any data set you could feed an AI, there's so much more to pull on. So I think that it's going to be interesting where AI is useful in years to come, but I don't think it can solve everything. It's kind of what I'm saying.